All right, section 9.3 is over surface area of cylinders. I'm going to try to build the case today that other than cubes, which I think we can all agree are the easiest shapes to find surface area of, I think the surface area of cylinder is the next easy. I think it's the easiest one other than cubes, even easier than a rectangular prism. That's the case I'm going to build today. Okay, and I'm going to support that by showing you a shortcut that you can also use. If you don't use the shortcut, you could probably argue, I think this is longer. Longer, maybe, not harder, longer. I'm going to show you a shortcut that saves you a few seconds off of your problems as you're doing surface area of cylinders. Now, we talked about surface area of cylinders on Thursday, and we talked about nets. Rectangular prisms have 6 faces. Triangular prisms have 5. Cylinders only have 3 faces. 2 of them are circular bases. And then we have one lateral rectangle. Here's your first blank there, rectangle. Now we know how to find the area of a rectangle, but this rectangle is a little bit different. They don't tell you how long it is. You'll be able to tell how tall it is because it'll tell you how tall the cylinder is, but we don't know the length of it unless maybe you remember me telling you on Thursday. Do you remember, Frank? That's right. Nice job. So because the rectangle wraps around the circle and the distance around a circle is called circumference, the length of the rectangle here is actually the circumference, or pi times diameter. And I've got your circumference and your area formulas up there on the board that you'll use this section for finding the surface area of a cylinder. So to find the area of the circles, we do pi r squared. In fact, one circle, now double it. Now you've got both of them. To find the area of the rectangle, we're going to do circumference, so pi d times h, and then we just add those two values together to find our total surface area. Okay. So just as Frank said, the length of that lateral rectangle is the distance around its circle base, which is called circumference. And the two formulas you'll need for this section are A equals pi r squared, which you remember from last chapter, and C equals pi d, which you hopefully also remember from last chapter. No new formulas, just using the ones you already are familiar with. You can see this picture here as an example of why it's a rectangle, because it's just a curved up, in this case, the soup can or the pepper can is just a piece of label that's actually in a rectangle, and they just taped it around. So it's been curved around that circle. All right. It says, first problem, it says, use the net to find the surface area of the cylinder. Round your answer to the nearest tenth. You'll notice that a lot of the questions on tonight's Big Ideas homework say round to nearest tenth. I'm not a fan of that, but I can't control it either. So that means instead of 2 decimal places, you'll want to just give 1 for the nearest tenth to make sure you're still rounding, see if it goes up or not. So still want to check that. Why don't we start with our 2 circles? To find the area of a circle, we do pi times radius squared. Pi times radius squared. Now, Maddie Yentes, is the 4 millimeters we have here the radius or the diameter of the circle? It is the radius. That's what we want to use then. So pi times 4 squared. Maddie, tell us what pi times 4 squared is. Remember, she has to square the 4 first before timesing by pi. 50.24. Okay. So we know that that top circle is 50.24. We also know the bottom circle is the same size, and it's going to be 50.24. Maddie, you want to go ahead and just double what you have and tell us what that combined area of the circles is? 100.48. Did I lose anybody in how we got the 100.48? Pi times 16, that's what 4 squared is, gives you 50.24, and there are 2 of those circles. We just doubled that. Okay. Now for the rectangle, we know the rectangle is 3 millimeters tall. What we need to find is how long the rectangle is, which it wraps around the circle, half of it on this side, half of it on that side. So we're going to find circumference of that circle. Now, Caden, the circumference formula is pi times d, not a difficult formula to use. But Maddie just said the radius was 4, not the diameter. What is the diameter of that circle? 8. Yes, double the radius and you have the diameter. So if I write pi times 8 or 8 pi, however you want to write it, that 8 pi is the length of the rectangle. Its width is 3. So I'm going to do 8 times pi times 3. And that's going to give me the area. Length 8 pi, width is 3. Multiply it all together. Frank, what do you get? $75.4. All right, so we're going to add 100.48 with 75.4. Or you can put a 0 there if you want to. Is it 75.4? Okay, let's leave it as 3.6. I was going to say that. Okay, let's leave it as 3.6. So Frank, you already let's round to the very end. Okay, the earlier we round, the sooner we lose accuracy. Wait to round to nearest 10th until you finish the problem. Okay, so we'll leave it as this for now. What's that going to give us? 175.84. Now let's round to nearest 10th. Are we going to say 175.8 or 175.9? 0.8, the 4 is not enough. So we'll say final answer is 175.9. And then it's an area problem.
Why would it be 9?
What 8, no, oh, sorry, it's not. Why did I don't know why I wrote that. You just said it was 8. I was so focused on the label that I'm not sure why I wrote the 9 down at all. Thank you. What is the label on this one? Area. Hunter? Millimeters squared. Excellent job. Okay. Now, right now, you might be saying, I think I could have done a rectangular prism in the amount of time you just did this one. And that you might be right. I'm going to show you a shortcut because what I think the most time-consuming part of this problem isn't the 4 times 4 times pi times 2. It's not the 8 times pi times 3. It's getting both these numbers as decimals and typing them into my calculator without making a mistake, which I watched several people do first period. Kind of like I just saw Branson do a moment ago, right? Like type something in, like, you type it in wrong, you got to start over, right? That takes a little time. So I'm going to show you how you can avoid getting the decimal until the very end of the problem. A little bit of a shortcut that you might like. Okay. Look at our next one here. It says find the surface area of each cylinder. Write your answer in terms of pi and round it to the nearest 10th. In terms of pi, that's going to be our shortcut. Let me show you how writing it in terms of pi saves you some time. Now there's no net to go off of here. So I have to know 2 circles, 1 curved rectangle. Let's do the 2 circles. There's one of them. Alexis, what's the radius of that circle? It's the 6. Yeah, the radius here is 6. Remember, radius goes halfway through. So my formula that I'm using right now is pi r squared. And so it's pi times 6 squared. And how many of those circles do I have? 2 of them. So just like I did for rectangular prisms and triangular prisms, I'll put parentheses and then 2. Okay, we're going to do all of this except times by pi. So Hunter, what's 6 squared? 36. Double it. Times it by 2 now. Okay, so 6 squared is 36. Times by 2 is 72. He's done everything he can except times by pi. Hold off on the timesing by pi. Now we have the curvy rectangle, which when I roll it out like this, which I'm going to erase this in a second because I don't want it to cover up my work, it's going to look something like that. We know the rectangle is 9 yards tall. That's already given to us. What we don't know is its length. We do know that it wraps around a circle. So we know that it's going to be the circumference. Ella, I get this to erase. To find the circumference of the circle, you have to multiply pi times diameter together. What's the diameter of our circle? $12. Yes, remember Alexis said the radius was 6, so that makes the diameter twice as long. And so the length of the rectangle is going to be 12 pi. The width of the rectangle is just 9. So I'm going to write this down real quick. 9 times 12 pi. Now let me erase the rectangle so it's not in the way. Ella, what's 9 times 12? 108. Still not timesing by pi yet. Writing it in terms of pi. So as of right now, no decimals. They both have pi symbols. So what I can do is I can combine my 72 pi's with the 108 pi's I got for that rectangle and get one large pi. Whitney, what do you get for 72 pi, or just 72 actually? What's 72 plus 108? $72 plus 108. You multiply them. $180. Now put the pi symbol there, and you have done everything you possibly can except multiply by pi. Now the advantage to doing this, Lainey, you with us? The advantage to doing this is that now instead of multiplying by pi twice and getting two different decimals to add in my calculator, Whitney only had to add 72 and 108. That's not terrible to type in. Now that we've got 180 pi, Whitney, go ahead and times your 108 by pi once. We only have to multiply by pi one time in our calculators. What's 3.14 times 180? All righty, 565.2. That's already rounded nearest tenth because we don't have any hundredths digits, and that's going to be yards squared. So let's recap here. In purple, we have our two circles. That was 72 pi, and you can just leave it as 72 pi. In red, we have the curved rectangle that wraps around our circles. Its height was 9, its length was the circumference, or 12 pi. That gave us 108 pi, and then we added the 72 pi and the 108 pi together, and instead of getting a whole bunch of decimals that type into our calculator, we only have to type in 180 times 3.14, and that's our answer. Let's do another one. Is it going to matter if the cylinder is laying on its side? No. You really can't change a cylinder. It's always going to have two circle bases in that curved rectangle. So regardless of how it looks. All right, let's start with the circles. There are two of them again. Okay. Lucas, what's the radius of the circle? It's 3. Yes, that's important here. The radius is 3. That's important because I have to use the radius when I'm doing area. So pi times radius squared, and I'm going to put the 2 in front of parentheses because there's 2 of these circles. Lucas, what's 3 squared? 9. 9 times 2? 18. Remember, he's not timesing by pi yet. So 18 pi is what we'll put, and that's both circles. Now for the rectangle. This one's going to look like a roll of paper towels. Maybe it's like hanging in your kitchen or something, right? You unroll it like that. So that's what it's going to look like when I unroll it. We know that it's 12 centimeters wide. I need to know its length. Now its length wraps around the circle. And so the circumference of the circle is pi times diameter. Frank, what's the diameter of the circle? Six. Yeah, they give it to us. So pi times diameter is pi times 6. There's your circumference. That tells you how long the rectangle is. So 12 times pi times 6. Frank, what's 12 times 6? 72. Now put the pi symbol behind it, just like we put the pi symbol behind the 18. We've got the area of our rectangle. We've got the area of our two circles. We're ready to add now. Natalie, what do you get when you add 18 and 72? $90. 18 pi and 72 pi just makes 90 pi. And now go ahead and times by 3.14. This is the shortcut. I think this saves a little bit of time. $282.74. Okay. So if I round this to the nearest, what was it, 10th, I believe again, is this going to be 282.2, 282.7 or 282.8? Leave it as 0.7. Okay, I'm just going to erase the 4 here so I don't get in trouble and make a mistake again. So 282.7, and that would be centimeters squared. I don't know. I feel like I've got a pretty good argument that this actually takes less space on your paper as well, and maybe a little bit less time, especially once you start doing some of these. If you like rectangular prisms, it's probably because you've done more of them. You started doing them last year, right? You've never done a cylinder before. The more of these you do, the quicker you become at them because you get better at it. I think these are easier. Other than a cube, I think these are the next easiest. Lucas. Okay. Did you use the pi button, Natalie? Okay, that's why. Okay. Okay. Which is fine, and I'll accept that. So you got 0.6 what, Lucas? Just 0.6? Okay. Okay. No, so Natalie, the 7.4 was using the pi button. Okay. And you rounded to 0.7. You did it correctly. I would accept that. So remember, that's a good point. Because we're doing circles, I'll accept pi button answers or 3.14. Okay. So just know that. All right. And then we've got this next problem that says how much paper is used for the label on the can of tomatoes. Now, how is this problem different from the other two we just did? Lucas? If I'm finding the area of the paper label, how is that different from doing the last problem we just did? Give it another shot. Yes, we are not finding the area of the bottom and top circles because there's no paper there. So the part of the problem where we just did the 12 times pi times 6, that's all we have to do. All we have to do is find that lateral rectangle, which in the last problem was 72 pi. So this actually cuts our work in half if we are finding lateral area, not the basis. So remember, lateral surface area, the label represents the lateral surface area. Lateral area is everything but the two bases. So in a can, they don't have no paper on the two bases. So we're just going to do the rectangle. And so the rectangle is going to look something like this. I'm going to unroll it. Probably a little bit longer than that, actually. That's as long as I can make it. So I know the can is 5.5 inches tall. That's given to me. I need its length. I need its circumference. Parker, what's the diameter of the can? 4. Remember, circumference formula is pi times diameter. So pi times 4. So Parker, tell me what pi times 4 times 5.5 is. Now, I'm going to have him go ahead and times by pi because there are no other pi's for us to combine. Remember, we're not finding the area of the top and bottom. So this is it. This is it. 4 pi times 5.5. What'd you get? 0.11. Did you use the pi button? Okay. And it says nearest 100, so we'll leave it like that. Now, he used the pi button. I know a lot of you probably use 3.14. I think you get 0.08. Yes. Okay, so I would accept 69.11 or 0.08 inches squared. And both those answers would be in my answer key on a test, just so you know. So I would accept both of them. This one says nearest 100, so we're not going to round it to 1 decimal place. We're going to leave it as 2. Questions? Why was this problem easier than the other two? No circle bases. Yeah, just the rectangle part. Exactly. Just the rectangle part, which is circumference times height. That's all we have to do. Now we have one more problem, which we will finish tomorrow. Remember, tomorrow is a work day, so we'll have time to get this problem done, which is number 17 in tonight's homework. And we'll look at some other ones. We'll do some more practice with cylinders just because they're the newest ones. So I'm going to have you guys go and wrap it up there. When the bell rings in 90 seconds to be discussed. Make sure I get your calculators back before I vote for me. Yes. Okay, number 17 on the 9.3 notes, or actually also the homework, says the cut wedge represents 1/8 of the cheese. So that sliver right there is 1/8. How much of the cheese is left then after the wedge is cut out? What portion is left? If 1/8 is gone, how many eighths remain? 7/8. Okay, keep that in mind. We'll want that later on in this problem. For now, though, part A just says, find the surface area of the cheese before it's cut. So when it's still intact, which when that cheese slice is still intact, that makes it a cylinder, just like all the other cylinders we did. Both in terms of pi, rounded to the nearest whole number, and as a decimal, rounded to the nearest 10th. Okay. So let's recap how we do cylinders real quick, because that's what this is. If you take that cheese slice and put it back in, it's a cylinder. So cylinders have 3 faces, 2 circular faces, and a lateral curved rectangle. And so every cylinder, you start by finding the area of your 2 circles. 2 times pi r squared. You have to know the radius. Then you have the rectangle part. We know how tall the rectangle is, and it's going to be as long as the circle is around, and that's called circumference. So circumference formula is pi times diameter. That's where 12 pi comes from, because the diameter is 12. I like to keep everything in terms of pi until the very end of the problem, and then times by pi just once, so I don't have to deal with all those decimals early on in the problem. Okay. Here's another example. Here's one that we can even do in our head. Pi r squared, the radius of this circle is 3. What's 3 squared? 9, and then 9 times 2 gave us 18. When you unroll the rectangle, it's going to be the circumference of the circle long, because it wraps around that circle. So the 6 pi, 6 is the diameter, pi is pi, and 6 pi diameter times pi gives us the circumference. So this is the circumference. This was already given to us. The width of the rectangle is 12, because that's the distance between the 2 circles. And so we did 12 times 6 to get 72 pi's. And then we can leave the pi's in terms of pi, combine them to make 90 pi. And then finally, at the end of the problem, we can times by 3.14 to see what that gives us. So with that in mind, let's check out number 17. Let's do our 2 circles. We have 1 circle on top. Now remember, we're finding the area before the piece is cut out. So we have the circle on top. We have a circle on bottom. How many circles is that? 2. We have 2 full circles. So 2 times pi r squared. What's the radius of the circle? What is it? 3? All right. What's 3 squared? 9 times 2? The area of both of our circles is 18 pi. We're just going to leave it as 18 pi. We're not going to multiply it out just yet. All right, so I got the top circle. I also have the bottom circle. And now I'm going to do the lateral rectangle. I'll use a different color for that. This one's going to be pretty long. I'm going to approximate it to be about that long. That didn't look good. Better. And my approximation is just that. It's approximation. I don't actually even need to draw the rectangle. It just gives me a visual. I know that the rectangle is 1 inch tall, because that's how tall the sliver was. And the sliver came from here. So I know it's 1 inch tall. The length of the rectangle is going to be 1 trip around the circle. And we call that circumference. So my circumference formula over there on the board says pi times diameter. Andrea, what's the diameter of our circle? 6. Yep. So it is going to be 6 pi long and 1 inch tall. So let me erase the rectangle now. Sorry if you just got done drawing it. I don't need it. Plus 6 pi is the length, because that's the circumference, times 1. So it's a rectangle. Length times width. The width is 1, the length is the circumference. What's 6 times 1? 6. So the rectangle is 6 pi. The two circles are 18 pi. How many pi's does that total? 24 pi's? You just answered the first part of the question then. Find the surface area of the cheese before it's cut, both in terms of pi, so 24 pi, and rounded to the nearest tenth. So what's 24 times 3.14? I'm going to use my approximation symbol, which is a squiggly equal sign. Shows you that I'm not exact here because I'm using 3.14. I'm rounding pi. What do you get, Maddox? 0.36. Excellent. Okay. Now they say to round as a decimal to the nearest tenth. And so Maddox, that's 1 decimal place. Would you say that your answer of 75.36 needs to stay as 75.3 or bump to 75.4? Got it. Excellent. So we're going to write 75.4 square inches, and we have the total surface area. Again, this is before that piece is cut out. What do you think is going to happen to the surface area after I cut that piece out? It's going to change. How? How's it going to change? Aiden? Yeah, you would think it would decrease. All right, we're cutting a piece out. That's what we're going to see happen here. Question is, how much is it going to decrease? Well, part B says, again, find the surface area of the remaining cheese after the wedge is removed. Round the estimated portion answer to the nearest whole number. Nearest whole number. Okay. So if 1/8 of the cheese wheel is now been removed, 7/8 remain. 7/8 of the top circle, 7/8 of the bottom circle, 7/8 of the rectangle are still there. So really 7/8 of the whole shape. So what I'm going to do now is, if the surface area of the whole shape is 24 pi, I need to find what 7/8 of that is. 1/8 is going to give me the chunk that I don't want. 7/8 gives me the chunk that's still there. How do I multiply 7/8 to 24 pi? Can I write 24 pi as a fraction? How would I turn 24 pi into a fraction? Do what? Over 100? About over 1. Now you turn any whole number into a fraction. If it's not already a fraction, just put it over 1. Would you guys agree 24 pi divided by 1 still 24 pi? Okay. Now, when I multiply fractions, I always look to see if something cancels. Does the 7 and 1 cancel? Does the 8 and 24 cancel? Yes. What number goes into 8 that also goes into 24? 8 itself. 8 goes into 24 8 goes into 8 one time. 8 goes into 24 how many times? 3. And what's 7 times 3? 21. So the surface area after I cut that wedge out, if 1/8 of it's gone and 7/8 of it's still there, that'd be 21 pi. The other class did it a different way. And maybe this makes a little bit more sense to you. They said that if 1/8 of it is gone and finding 1/8 of a number is just dividing by 8, they divided 24 by 8 to get 3 pi. And then since that 3 pi piece is leaving, they subtracted 3 pi from 24 pi to get 21 pi, which is what we have. So what's 21 times pi approximate to? Hannah Lindley, what's 21 times pi? Okay, 65.94. It says rounded to the nearest whole number. Would you leave it as 65 or bump it to 66? Okay, so we're going to say it's about 66. And before you write that down as your final answer, it's not. Something interesting happens when you remove 1/8 of the cheese wheel. If that chunk is now gone, and we have 66 about square inches of cheese left, you're missing something. Aiden, do you see what we're missing? Don't subtract the numbers. There are two surfaces that have now been created after we cut that wedge out. They weren't on the surface before. Now they are. Branson, do you see them? Where are they? Exactly. That piece right there, and then that piece right there are now on the surface. When you cut that wedge out, okay, cutting a cheese wheel, maybe not something that we can relate with. Maybe you've seen like a cake be cut, right? When you cut that cake out and you take a piece of cake out, it makes those surfaces now that are now on the edge that I need to apply. I need to add those on. So by taking a piece out, it actually created more surfaces. Now the length of those rectangles are both 3 because this cake was cut, or this cake, you got me thinking cake now. This cheese wheel was cut from the center. So the radius of 3 tells you how long the rectangle is. And it's still 1 tall. So what's 3 times 1? 3. So that rectangle is 3. And that rectangle is 3. So take our answer of 66 and add 3 and 3 or 6 more to it. And that gives you a final surface area rounded to what? What's 66 plus 6? 72. So it's about 72 square inches. So obviously the surface area decreased from 75.4 up here, 75.4 to 72. But did it decrease as much as you thought it may have? Probably not. Because by having to add the extra 6 in for those 2 rectangular surfaces that weren't there before, it actually only lowers the surface area by about 3.4, which is crazy. You take up 1/8 of the cheese wheel gone. Now, if we were talking about volume, yes, 1/8 of the cheese is missing. But on the surface, there's more surfaces that were created by doing that. All right, that was number 17. Now, as you're working your way through the 9.3 homework, you're only going to see cylinders, and obviously this problem here that we've done. There are 2 things that I want you to be on the lookout for that could cause you to get an answer wrong, even though you've done everything right. Number 1, are you rounding to the correct number they want you to round to? Are you rounding to the nearest 10th, rounding to the nearest 100th? Make sure you read the instructions so you know what they want you to round to. Number 2, there's at least one problem that says find the lateral surface area. The lateral surface area is what we did for this problem. Remember, the lateral surface area is the area of everything but the 2 bases on a shape, on a prism or cylinder. So on this tomato can, there isn't paper on the top, there isn't paper on the bottom. It's like a typical soup can that has a label that wraps around it. So they only want you to find the lateral surface area here, which means the rectangle part. That means I need to know how tall the rectangle is. I already do. And I need to know how long the rectangle is. I don't. So I have to find the circumference of that rectangle, pi d. The circumference here, diameter was 4, so pi 4. then take pi times 4 times 5.5 and just get the rectangle. You don't actually have, so in a sense, if I ask you to find just the lateral surface area, you're only finding that chunk right there. You don't have to do the other half of the problem. You don't have to find the two circles. So keep that in mind. If you get one wrong and you're like, I've done everything right, the instructions may have only wanted the lateral surface area. You gave everything. So erase your two circles and just find it from there. So we have 9.1 homework due Wednesday, tomorrow, and this homework is due on Thursday.